Difference between translational motion, rotational motion, and rolling. In case of a translational motion, the velocity of each point of a body is equal to the velocity of center of mass. For example, we consider 4 different points A, B, C, and D. If the body is moving with a velocity v, then in this case velocity of A is equal to velocity of B is equal to velocity of C is equal to velocity of D is equal to v center of mass. In case of rotation, if O point is fixed, then body is moving about a fixed axis with some angular velocity omega. Then the velocity of each point VA, VB, VC and VD are different, which is given by velocity of point A is given by r omega I cap, whereas velocity at B is given by r omega minus j cap. VC is given by minus r omega I cap and VD is given by minus r omega j cap. Means each point have the same magnitude but different direction. In case of rolling, means the point O is not fixed, the body is in translately as well as the rotation motion. In this case, the velocity of A is given by v center of I cap plus r omega I cap. Means velocity of A is of magnitude v center of mass plus r into omega. Velocity at point B is given by v center of mass I cap minus r omega j cap. That is magnitude of VB is given by v center of mass k square plus r omega square under root. And velocity of C means velocity of a bottom point is given by v center of mass I cap minus r omega I cap. Means its magnitude is given by v center of minus r omega. Again, the velocity of point D is given by v center of mass I cap plus r omega into j cap, and VD, the magnitude of VD is given by under root of v center of mass k square plus r omega ka whole square. Now, from all 3 and 4 points, we consider the velocity at point C is less than the velocity of point D and is less than velocity at point A. Means as we move from bottom to top, the velocity of a point increasing considerably. In case of a pure rolling, v center of mass is equal to r into omega. Means the velocity of a bottom point is equal to 0. Velocity of a diametric point VB or VD is equal to under root 2 times of v center of mass, and velocity of a top point is given by 2 velocity of center of mass. Now we just focus the center of mass. Center of mass, it is a point inside or outside the body at which whole mass of the body is supposed to be concentrated. Determining the point, we have the relation position of center of mass is given by m1 r1 plus m2 r2 upon m1 plus m2 for 2 particles. For more than 2 particles, the same equation is given by m1 r1 plus m2 r2 up to mn rn and divide by m1 plus m2 up to mn. Now, in Cartesian form, the position of center of mass of x coordinate and y coordinate is given by the equation for x m1 x1 plus m2 x2 up to mn xn divide by m1 plus m2 up to mn, and for y coordinate m1 y1 plus m2 y2 up to mn y1 divide by m1 plus m2 up to mn. For uniform body, the x coordinate of center of mass is determined by the equation 1 upon m integration of x dm, and y center of mass is determined by the equation 1 upon m integration of y into dm. Example, on the basis of variable mass or uniform density, find the center of mass of a rod from one end if the linear density of the rod is dm by dx is equal to k into x. Now we have dm is equal to kx into dx. Now from above relation we have x center of mass is equal to 1 upon m integration of x into dm. In this case, mass is not constant, means we have to determine the total mass m is equal to integration of d into m. Now from the formula we substitute the value of dm in numerator as well as denominator and integrate from 0 to L. We get the value of x is equal to 2L by 3. Now x center of mass is equal to 2L by 3, whereas the y coordinate of the rod is remains 0, means position of center of mass is given by 2L by 3 comma 0. Now the another quantity which is called moment of inertia, which is given by I is equal to m1 r1 square plus m2 r2 square plus